Hello guys, how are you today? So today I'll be explaining the Physics Chapter 8 course questions from Level L. So let's start with the first question. The first question is define energy. What is the definition of energy? Whenever they say energy, they mean it is what? They mean it is the ability, okay, to cause a change that can take different forms in different bodies. So what you need to know is that energy is the ability to cause a change, okay? And this change can take different forms in different bodies, okay? So if they asked you to define energy, it is the ability to cause a change, and this change can take different forms in different bodies. They told us in question number 2, state the principle of conservation of energy. What is the principle of conservation of energy? This is applied for what? For the isolated systems, okay? So for any isolated physical system, there exists a quantity termed energy. So in the isolated system, there exists a specific amount of energy, and it's gonna stay constant. It's not gonna change, okay? In an isolated physical system, there is a quantity. There is a specific quantity of energy that remains constant regardless of any internal interactions. So, in the isolated system, there is a specific quantity of energy that remains constant regardless of any internal interactions. This is the principle of conservation of energy. A way that you can think of it is, let us say we are gonna have two people, person A and person B. Okay? A and B together, they have what? They have 250 dirhams and 250 dirhams. Let us say what happens. There is an internal interaction where person A gives 50 dirhams to person B. So now person A will have how many dirhams? He will have 200 dirhams. And person B will have how many dirhams? They will have 300 dirhams. Okay? So as you can see, person A lost money and person B gained money, but the total amount of money here, which is 500 dirhams, is the same as the total amount of money here, which is also 500 dirhams. So very simply, this is the principle of conservation of energy, where these two people are in an isolated system. There's a specific quantity of energy, which we will make the dirhams, that will remain constant regardless of any internal interaction. Okay, very simply, that is to grid. We'll move on to question number 3. In question number 3, it says, explain how energy is in bottled gas can help you make hot cup of coffee. Discuss in the class where the energy is in the bottled gas comes from. Can you trace it back in time to the solar energy? So very simply, first thing, explain how energy in bottled gas helps you make a hot cup of coffee. We know what happens is that the bottled gas will undergo combustion. So we will put over here combustion. And this combustion will cause what? It will cause the chemical potential energy to be released in the form of heat. So the gas will undergo combustion, and this is the chemical potential energy that is released to form what? To form heat. So the gas will undergo combustion to form heat by experiencing combustion, and what will happen? The chemical potential energy is released, and then the heat will form. Now they told us in the second part, discuss in class where the energy in bottled gas comes from. Can you trace it back to solar system? So to the solar energy. The solar energy, okay, it will go to the plants. So solar energy is absorbed by the plants, okay, let us say. And then the plants, they will what? They will die. Okay, when the plants die, they will form what? They will form fossil fuels. When these fossil fuels are burnt, what will happen? We will have that a formation of gas. So very simply, the solar energy will be absorbed by the plants, and then the plants will die under specific temperature and pressure. They will turn into fossil fuel, and after this there will be fractional distillation of the fossil fuel, and then they will produce what? They will produce gas for the house use. Okay, that is pretty much it for question number 3. Let us move on to question number 4. In question number 4, they said, how can the energy supplied by a tree or supplied to a tree by the sun help pull a train? We know, first of all, we have what is happening. We have that the sun will give energy to the tree. Okay? So sunlight energy will be converted into the tree. And this energy over here, it is what? This energy over here, it is the chemical energy. It will be stored as chemical energy by photosynthesis. Okay? Here in the sun, it is what? It is light energy. Okay? So light energy will go to a tree and it will become chemical energy. Now this chemical energy, what will happen to it? We will burn the tree, okay? So after burning the tree, we will release what? We will release the chemical energy in the form of thermal energy, okay? So this is, we are heating it. And after we are heating it, after we are burning the tree, what will happen? We can use this heat to do what? We can use this heat to boil the water. So what happens? This thermal energy, we will use it to boil the water, so the water will gain kinetic energy, okay? So it will start to move. So this kinetic and the energy, what? It will be used to move the train, or it will be used to pull the train. So again, the sun, which has light energy, it will give the tree chemical energy by photosynthesis. Then when we burn the tree, we will get heat, which is thermal energy. This thermal energy is used to boil the water, which will give us kinetic energy. And this kinetic energy of the steam will be used to pull the train. Very simply, that is it for question number 4. We move on to question number 5. In question number 5, they said, describe 3 forms of energy. Explain the transfers of energy involved in making a car run using fossil fuel. Hence, start with solar energy. Okay, let us start with part A. What are the 3 forms of energy? 3 forms of energy we have is the internal energy, and the heat energy, and the chemical energy. Okay? The internal energy, it is what? The internal energy is the energy of the random thermal energy of particles. So the random thermal energy of particles. It is also the intermolecular energy, or the energy in between their molecules. So intermolecular energy. And then finally, it is the chemical potential energy. Okay, so it is random thermal energy, intermolecular energy, and chemical potential energy. For the heat energy, it refers to the hotness of a body, how hot a body is, okay? And finally, for chemical energy, it is a form of potential energy, and usually we will find this potential energy, where this chemical energy, we can find it in chemicals such as fossil fuels and food. So very simply, that is it for part A. We'll now move on to part B. In part B, they said, explain the transfers of energy involved in making a car run using fossil fuels. They said, start with solar energy. So look what happens. Solar energy, it will be given to what? It will be given to the living organisms. Alright? So the solar energy, which is light energy, will be given to the living organisms as chemical energy. Okay, so this chemical energy will move from the living organisms when they die, okay, and they will be changed into fossil fuels under certain heat and pressure. So when the living organisms die, they will be still fossil fuels. They will be turned into fossil fuels. So they will have the chemical energy. And then the fossil fuels are burnt. What is gonna happen? When the fossil fuels are burnt, their energy will be released as what? It will be released as mechanical energy and thermal or heat energy. So very simply, explain the transfer of energy involved in making a car run using fossil fuels. First thing we have is solar or light energy. It will give the energy to living organisms as chemical energy. They will die and be transformed into fossil fuels under high temperature and pressure, which is still chemical energy. They will be burnt and they will release what? Mechanical and thermal energy that will be used to move the car. We move on to question number 6. In question number 6, it says, state and explain Einstein's mass energy equation. I think this is very famous. E equals mc squared. Yeah. What does it mean? Einstein's famous equation, which is E equals mc squared, which is the mass energy equation, explains the equivalence of mass and energy, okay, based on this equation. So look, okay, where E is the energy, okay, m is the mass, and c is what? And c over here, it is what? It is the speed of light squared, okay? So now, this is question number 6 done. We move on to question number 7. It says, what does internal energy refer to? Very simply, internal energy refers to 3 things. The first thing it refers to is the random thermal energy, okay? This random thermal energy is what? It is the energy found in the particles of a body due to their random motion. The second thing that they have is the intermolecular potential energy. So the intermolecular potential energy, okay? What is intermolecular potential energy? It is the energy, the potential energy that is happening because of the relative positions of the molecules. So due to the positions of the molecules, okay, they will have a certain type of energy. And then the last thing we have is the chemical potential energy. Okay, this chemical potential energy, it is what? It is the energy stored in the bonds between atoms forming molecules. So when you break these bonds, you will release the chemical potential energy. Very simply, that is it for CQD number 7. We'll move on to CQD number 8 grid. In CQD number 8 grid, they said define heat energy. Heat energy. Okay, so again, for heat energy, we have 3 types of energy. The first energy we have for heat energy, it is what? It is the random thermal energy. So, random thermal energy. This is also under the category of internal energy. So, internal energy is random thermal energy, and it is also under what? It is also under heat energy. Then, the next thing we have is radiant energy. And then the thing we have after that, it is what? It is internal energy. So we have random thermal energy, radiant energy, and internal energy in heat. Random thermal energy as in hot iron, radiant energy as in the infrared radiation radiated by a hot iron, and then the internal energy that is hot as in like hot steam. Now we move on to number 9, define chemical energy. What is chemical energy? Chemical energy is a form of potential energy that is found in chemical fuels, in food and in other substances, okay? So usually, where do we find chemical energy? Chemical energy, it is first of all a form of potential energy, okay? This form of potential energy, so how can we find this chemical potential energy, or where we can find it, okay? Usually we can find it in the chemical fuels, okay, the food, and in other substances. So that is it for question number 9. Let us move on to question number 10. In question number 10, they said, what is radiant energy and what is a photocell? First of all, radiant energy, it is what? Radiant energy is another word for the electromagnetic radiation. So radiant energy is another term for electromagnetic radiation. Okay? Okay, so radiant energy is another term for electromagnetic radiation. What is electromagnetic radiation or radiant energy? It is a form of energy, okay? A form of energy that can travel in vacuum. Okay, very simply, radiant energy is a form of energy that can travel in vacuum. Another term for it is electromagnetic radiation. Now they asked us, what is a photocell? Very simply, a photocell is what? A photocell, it is an instrument, okay? An instrument in which light falling on a metallic surface in a vacuum. So an instrument in which light falling on a metallic surface in a vacuum knocks the electrons out, so knocks the electrons out of their surface, okay, and these electrons that are knocked out of their surface, they will drift across to another terminal, so drift across to another terminal, and like that they would have generated what? They would have generated an electric current. So they generate an electric current. Okay, so very simply, what is radiant energy? Radiant energy, another word for it is electromagnetic radiation. It is a form of energy that can travel in vacuum. An example would be light. What is a photocell? A photocell is an instrument in which light falling on a metallic surface in a vacuum knocks the electrons out of their surface. They will drift across to another terminal. They will generate an electric current. That is very simply the definition of a photocell. Let us now move on to CQD number 11, okay? They said arrange the components of the electromagnetic spectrum in increasing frequency. So remember this spectrum over here. Okay, so very simply, look what we can do. You could just take a bunch of waves and you could draw big, and then it starts to get smaller and then 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 smaller, okay? You can draw it like this in the start, and then you can divide it into 7 fragments, okay? The first fragment is from here. Second fragment is from here. The third fragment is from here. Fourth one is here. The fifth one is here. The sixth one is here, and the seventh one is here. So let us name them all. The first one, which has the longest wavelength, it is what? It is the radio waves. Okay? So the radio waves have the longest wavelength. After the radio waves come the microwaves. After the microwaves comes the infrared radiation. After the infrared radiation comes the visible light. I don't know how to fit it, visible light. Then, after the visible light, over here we will have what? We will have the ultraviolet radiation. So over here it is the UV. Then, over here it is what? It is the X-rays. And then finally, the last one over here, it is the gamma rays. So, radio waves have the biggest wavelength, microwaves get smaller, infrared radiation smaller, visible light smaller, ultraviolet smaller, X-rays smaller, and gamma rays have the smallest radiation. Now, if we're doing it from wavelength, it would be like this. So this is the what? Increasing wavelength. But we know that the frequency is the opposite, and they need the frequency. So you would draw it like this way, and you would write it like this. Increasing frequency. So very simply, the increasing wavelength is going to this direction, towards the radio waves, whereas the increasing frequency is going to the other direction, which is towards the gamma rays. Alright, let us move on to CQD number 12. In CQD number 12, they said, what can be said about the speed of all electromagnetic waves in vacuum? So what does CQD number 12 say? It says, what can be said about the speed of all electromagnetic waves in vacuum? In vacuum, okay, all electromagnetic waves travel at the same speed. So in vacuum, all electromagnetic waves travel at the same speed, okay? Which is the speed of light, which is 3 times 10 to the power of 8 meters per second. We move on to question number 13. In question number 13, it says, determine the type of electromagnetic radiation used in each appliance. In a TV radar, what does a TV radar use? A TV radar uses radio waves, okay? So it uses radio waves. Why does it use radio waves? It uses radio waves to transmit signals. We move on to the tanning bed. The tanning bed uses UV light or UV radiation. Why does it use UV light? Because, well, UV light is the thing that will make us tan. Then, medical imaging of bones. This is very simply the X-ray. So whenever you see medical imaging of bones, it's X-ray. Now, closed contaminator imaging. To view closed contaminator imaging, okay, we will use the gamma rays, okay? So the gamma rays are used for closed container imaging. The medical imaging of bones is used in X-rays. The tanning bed is used in UV light. The television radar is used in the radio waves. So very simply, that is it for CQD number 13. We move on to number 14. In number 14, it says, in a stretched bow, where is the elastic potential energy stored? Is it stored in the bow, in the arrow, or in both? Hint, only the bow changes its shape. Okay, what does it mean, elastic potential energy? Elastic potential energy is an energy that when, no matter how you change the shape of an object, it will return back to its normal shape. So take a rubber band, for example. No matter how much you stretch it, unless you cross the elastic limit. If you cross the elastic limit, then it will be changed, it will be deformed forever, you will not be able to change it. But as long as you are in the elastic limit, then you can stretch it and change its shape as much as you like, and still it will go back to its normal shape, okay? So the bow, they told us it's the only thing that will change its shape, so definitely the bow is going to be the thing that has elastic potential energy. The arrow will not change its shape, so it will not have elastic potential energy. We move on to question 8.6. It says conservation or permanence and transformation of energy. When coal is burnt in a power station to generate electricity, the efficiency of the system is about 40%. What does this mean? If the efficiency is 40%, that means there's 60% of the input energy lost, which is not a good thing at all, of input energy lost. Very simply, that is it for question number 15. We move on to question number 16. In question number 16, they said a windmill uses wind energy to operate a current generator which lights a light bulb, okay? Which of the following forms of energy is or are not involved in the process? So they need what? They need which forms of energy are not involved in this process. So we use kinetic energy for sure. We have some energy lost as heat. In the generator, we use electrical energy. We don't use chemical potential energy, and we don't use gravitational potential energy. So look, windmill uses wind energy. This is kinetic energy. Then, of course, there's heat energy being released. Then it operates a current generator to turn on a light. There is definitely for sure electric energy. But we did not use chemical energy and gravitational potential energy. So you will circle D and E. We move on to 17 grid. In 17 grid, they said, state the energy transformations that occur in the following devices. In a battery, what happens? It will change the energy from chemical energy, okay? It will change it all the way to electric or electrical energy. For a candle, it will change what? It will change the chemical energy into what? It will change it into the light energy. For the electric motor, it will change what? It will change the electric energy into mechanical energy. So electric to mechanical. And then finally, a solar panel, it will change what? It will change the radiant or solar energy. So radiant energy, it will change it into what? It will change it into electric energy. So battery, chemical to electrical or electric. Candle, chemical to light. Electric motor, electrical or electric to mechanical, and then finally solar panel, it is radiant to electric. 18 grid, determine the energy transformations in each of the following electricity generating devices below. So these are electricity generating devices. So this is a hint then that the energy being produced is electric energy. So we can just put for all of them that electric energy is being produced. Okay, for the first one, we have a wind turbine. A wind turbine will use the kinetic energy in its motion, and it will transform it into its electrical energy. The nuclear reactor will use nuclear energy, and it will transform it into electric energy. Solar panels will use solar energy, and it will transform it into what? Into its electric energy. We now move on to section 8.7, energy conservation, preservation, and the environment. Okay, give 2 reasons for saving fossil fuels. Very simply, 2 reasons for saving fossil fuels is that it is a limited resource. So definitely it is a limited resource. If we use it all up, okay, then there will be no more fossil fuels left for the future generations to use. So it is a limited resource and we need to save it. The second thing is that burning fossil fuels is contributing to global warming. And if it's contributing to global warming, then this is something very dangerous. And if it's dangerous, then we definitely should not be doing it. So definitely, fossil fuels, they are resources that are limited. So because they are limited, we have to save up for future generations. Okay, and fossil fuels also contribute to the global warming. Okay, one should save the environment from being poisoned by pollutants like excessive carbon dioxide, which contributes to the greenhouse effect, and acidic acids, which cause acid rain and destroy forests and lakes. Very simply, that is it for question number 19. We move on to question number 20. In question number 20, it says, give 1 consequence of global warming. They said 1 consequence, so you have 4 consequences to choose from. Okay, you can choose any one of them. So let us think together of 1 consequence of global warming. What is global warming? Global warming is the gradual increase of the temperatures. So if it's the gradual increase of temperatures, then that means the absorbed heat, okay, the absorbed heat due to excess carbon dioxide could increase or could rise the planet's temperature up to 2 to 5 degrees Celsius in the next 50 years. Now this is not something it's to take lightly, because if it increased 2 to 5 degrees, imagine the summers. So instead of the average temperature being, let us say, 55 degrees in the summer in the UAE, just like estimating, then it would be 60 degrees. 60 degrees is gonna be very much more unbearable than the 55 degrees. So for sure, global warming will cause what? It will cause the absorbed heat due to excess carbon dioxide to increase the planet's temperature up to 2 to 5 degrees in the next 50 years. Not only that, this would also cause the waters in the ocean to rise due to the melting of the ice caps because of the increase in temperature. And because of the increase of temperature, the warmer air will reduce the difference between the surface of the layers, okay, and this will reduce the conduction of geothermal heat. And this will contribute to the melting of the ice caps. And then finally, because of the melting of the ice caps, the result will be that the water will expand and it will increase, it will rise, and it could flood and destroy places where people live. So this is something definitely we do not look up to. Okay, we move on to question number 21. It says, define the greenhouse effect and identify the 2 main gases responsible for it. What is the greenhouse effect? The greenhouse effect, it is the heat trapping. So, the heat trapping effect, of the atmosphere, okay, which is known as the greenhouse effect. So the greenhouse effect, it is known as the heat trapping effect. It is mainly due to 2 gases. These 2 gases are what? They are water vapor, and carbon dioxide, CO2. So what happens? The water vapor, it is gonna what? It is gonna absorb the most energetic infrared radiation given off by the Earth, okay? And the carbon dioxide is gonna absorb the least energetic infrared radiation. And this is not something good, because then if it's given off from the Earth, it will not be able to bounce back to the Earth, and the Earth may become colder if there's a lot of water vapor in the greenhouse effect. But if we have an increase of carbon dioxide, what would happen is that what is it called? The infrared rays, they would bounce from the sun, they would reach the Earth, and they would bounce back up. But since they do not bounce back up and they do not go through the sun because of the amount of carbon dioxide concentration, because they will not go back to the sun, then they will be trapped on the Earth, and this will cause what? This will cause the global warming, very simply. We'll move on to section 8.8, keeping carbon dioxide in check. Give 2 ways to reduce fossil fuel consumption. 2 ways to reduce fossil fuel consumption, for example, is to use a natural gas instead, or to use hybrid cars because of their efficiency, so use hybrid cars. Other ways you have is to improve the insulation of buildings, to use the solar energy, and to use the air conditioning. Very simply, these are multiple ways to reduce fossil fuel consumption. We move on to question number 23. In question number 23, it says, what are some methods that can be used to reduce the consumption of fossil fuel? To reduce the consumption of fossil fuel, we have some methods. These methods could be what? To use hybrid cars. Okay. To use natural gas. Okay, to improve the insulation of buildings. So, improve insulation of buildings. Also, one they had from the previous question was to use air conditioning. Use AC here, it's not alternating current, it's air conditioning. And then finally, it is what it is, the use of solar energy. Use solar energy. Very simply, that is it. We move on to section 8.9, nuclear energy. In section 8.9, we have question number 24. It says, what type of nuclear reaction is used in a nuclear power plant? Here you should know that the nuclear reaction used in the nuclear power plant, it is nuclear fission. So, the nuclear fission, it is used in a nuclear power plant. What is nuclear fission? Nuclear fission is when one heavy radiating, let's say nuclei, will separate into 2 smaller nuclei, and it will release a lot of energy with it. Now they said, name 2 disadvantages of nuclear power. You have, first of all, the high price, which is an disadvantages, so high price. After that, you have that it is very radioactive and very dangerous to use. Okay. After that, there could be some nuclear weapons being used. Okay. After that, we have the psychological bias, that some people, they are scared. They have heard many stories probably, and they are scared to use any type of nuclear energy, so psychological bias. So I gave 4 disadvantages, but if they said 2 disadvantages, you would choose any of these 4. So either from the high price, from the radioactivity, from the nuclear weapons, or from psychological bias. We move on to section 8.10. Let me just check how much we have left. Yeah, not too much. Define the term renewable energy. What is renewable energy? Renewable energy refers to the form of energy that will not run out like fossil fuels do. So very simply, it is a type of energy that does not run out, that can always be renewed. Okay? Describe how hydroelectric energy is obtained and how it generates energy. Okay, very simply, from its name, hydroelectric energy. It is electric energy made from water. What is happening? They are telling us that it will convert the gravitational potential energy of water stored in dams into kinetic energy used to rotate turbines connected to electric generators. So you have the dam over here. Okay, this is the water that is stuck in the dam. And then this is what? Gravitational potential energy. Then we will have what? We will have the kinetic energy, and we will have, let us say, the turbines, like this. 1, 2, 3, 4. And then the water might overflow. So this is what? An increase in gravitational potential energy. And then it will flow down as kinetic energy. So because it is moving, it is going to become kinetic energy. And this kinetic energy will be used to rotate the turbines connected to the electric generators, and then they will create electricity. Okay, so very simply, if they asked you, how is hydroelectric energy obtained? Very simply, you would say that it is obtained by converting the gravitational potential energy of the water stored in dams into the kinetic energy used to rotate the turbines connected to the electric generators. Okay, we move on to question number 28. Grid, list 4 sources of renewable energy. We have wind power. This is a renewable energy. We have the hydroelectric power, so hydroelectric. We have tidal power. We have waves energy. We have ocean thermal energy. We have geothermal energy. And then we have what? We have solar energy. And then we have biomass energy. And then we have hydrogen gas. Okay? So very simply, what is happening? We have wind energy. We know it is the energy done by the wind. The wind turbines will turn and they will create electric energy. Hydroelectric, it will be from gravitational potential energy of water stored in dams. They will fall as kinetic energy, and they will rotate the turbines that will create then the electric energy. Tidal is how the tide moves. The tide could move back and forth. So if it moves forth, it might move move by kinetic energy the turbines that are found in the object or the thing, I don't know what we place in the sea, and then we will get energy. Same thing for the waves, how the waves move back and forth. If they move back, then they are removing the water, but when they move forth, they are increasing the water, and this difference will create the electrical energy. Ocean thermal energy, it is that at the bottom of the ocean, the water is colder than at the top of the ocean. So what they will do, they will use this difference in temperature to create what? To create energy. Geothermal energy is the heat energy coming from the earth. Solar energy, we know that it is the energy from the sun. Biomass energy is the energy from organic material, for example, from the waste products of the cow or from dead organisms or whatever. And then finally, hydrogen gas, usually they are used in the hydrogen fuel cells. Okay, we move on to CQD number 29. Here, different methods of generating electricity exist. These methods have advantages and disadvantages. Determine the disadvantage of each of the following methods. Wind power. What is the disadvantage of wind power? So using wind power on a large scale will raise issues of visual impact. So it will have it might not look nice. There might be a lot of noise due to them because they are huge, and local wildlife because the birds might come and they might hit themselves into the turbine. Hydroelectric energy. A disadvantage of hydroelectric power is that suitable sites are often a long way from where the electricity is needed. On the other side, constructing water dams involves burying large areas underwater, a situation that could cause real environmental and ecological threats. So, not located in areas where electricity is needed, in areas. So again, the hydroelectric energy is not located in areas where they are needed, okay? Another thing is that they would need us to bury large areas underwater. And this causes environmental and ecological issues, okay? Issues or threats. So that is it for the hydroelectric energy. We move on to the tidal energy. In the tidal energy, it says what? Or what is a disadvantage for the tidal energy? A disadvantage for the tidal energy is that they are expensive to build and they are bad for the environment. So bad environmental, what did I write? Banned, okay. Bad environmental impacts. Okay, that is it for the tidal. Now, what is the disadvantage of the geothermal energy? While geothermal energy as a source of electric power, it is very inefficient. It does not give us anything. So again, disadvantage of wind power is that it has visual impact, noise impact, and a bad effect on the wildlife. A disadvantage of hydroelectric power is that it cannot be found in places where the electricity is needed, and it is also it is an environmental and an ecological threat. Tidal stations are expensive to build and they are bad environmental impacts. The disadvantages of geothermal energy is that the source of electrical power, it is very inefficient. Okay, now we finally move to the last. So, question number 30. Describe how energy can be generated from microbes. Very simply, genetic engineers may be able to design microbes that will use sunlight energy to turn carbon dioxide into natural gas or produce hydrogen gas. So you can say what? That genetic engineers, they can design microbes that use sunlight energy to turn carbon dioxide into natural gas or hydrogen gas. So that is it for this video. Thank you guys for watching. I hope you enjoyed and have a wonderful day.